Let's continue to number 8. Question number 8 is about electrical circuit and electrical quantities. 8a. Figure 8.1 shows two resistors X and Y in series. Complete the table below using only the symbols I and R alone or in combination. Now let's take a look at resistor X. The resistance equals to R, the current equals to I. Potential difference is the product of resistance and current. Therefore, for this column, we fill in I, R. It means that it is the multiplication of current and resistance. And then for resistor Y, resistor X and resistor Y are joined in series or are arranged in series. Therefore, the current flows inside resistor X equals to the current flows inside resistor Y. So, for the current in resistor Y, just fill in I, the same as the current inside resistor X. Then for the power, power equals to I squared times R. The current inside resistor Y is I, so it's still I squared. But the resistance inside resistor Y is 2R, so it has to be multiplied with 2R. The answer then equals to 2I squared R. Let's fill in this into the provided space. So the power equals to 2I squared R. The 2 comes from the resistance inside the resistor Y. Let's continue to question 8b. Figure 8.2 represents the system used to transmit electricity from a power station to a factory. The power station generates 11,000 volts and supplies a current of 750 ampere. The total resistance of the power lines between the power station and the factory is 1.5 ohm. Calculate the power output of the power station. To calculate the power output, we use the formula power equals to voltage times current. The voltage is 11,000 and the current is 750 ampere. So the result is 8.25 times 10 to the power of 6 watt. Write down the answer on the provided space. 8.25 times 10 to the power of 6 watt. Don't forget the unit. Question B double I. The potential difference across the 1.5 ohm of the power lines. To calculate the potential difference, we use the formula V equals to I times R. V is the potential difference, I is the current, and R is the resistance. The current flows is 750 ampere and the resistance is 1.5 ohm. So we get 1000 1125 volt. Write down the answer on the provided space. 1125 volt. Again, don't forget the unit. Question 8b, III. The power supplied to the factory. To calculate the power supplied, we have to calculate the voltage supplied to the factory. The voltage supplied to the factory equals to the voltage from the power station, which is 11,000, minus the voltage loss during the transmission, which equals to 1,125. We get this number, 1,125, from the previous question, question 7b. So, the voltage supplied equals to 9,875 volt. Then, to calculate the power supply, power equals to the voltage supplied times the current. The voltage supplied is 9,875 times the current is 750. The result is quite big, so we have to consider the number of significant figures used in the problem. We will limit our answer by only 2 significant figures. So, the result is round off into 7.4 times 10 to the power of 6 watt. Write that down on the provided space. 7.4 times 10 to the power of 6 watt.